Recording is on.
Food microbiological risk analysis. In recent years, Dr. Liu published about 50 papers in SCI or EI journals on the food safety topic. He is also the primary developer of the predictive modeling platform named MircroRisk Lab, and 10 other web tools for food microbiology and microbial risk analysis. That's quite a lot. So please, the floor is yours. And thank you for taking the opportunity and accepting the invite to talk to us today. Thank you.
Okay, thank you. Thank you, Brand, and also Christina. And thanks to Natalia and Jen for the invitation. And good morning, afternoon, or evening, everyone. And I'm Yangtai from the University of Shanghai for Science and Technology. I'm very honored to join the session as a member of yICPMF. And today, I would like to provide an introduction of MircroRisk Lab. It is a free modeling tool from my research group, and we developed this for predictive microbiology and further for the microbiological risk assessment. Okay, so let's start. I hope you can see the screen, and perhaps maybe you haven't heard of this tool, so I will first provide its access link, and you can use your internet or use your mobile phone to scan the QR code. And for this session, and I will introduce the MircroRisk Lab and provide case studies for its main function. And the presentation will be too long, so you can ask me questions if you want. You can break me anytime, okay? And okay. So I would like to first introduce to you some background of this tool. Okay. And first of all, this is okay. So MircroRisk Lab, it is a integrated freeware for predictive microbiology modeling research, as you see in the title. And if you attended the previous lectures of yICPMF, and I think you will know that the predictive modeling of microorganisms is a task of describing microbial behavior using appropriate mathematical equations. And this is essentially a mathematical program, and more specifically, an inverse program of solving initial values. So like well, you know the kinetic parameters like lag or lag tide or the specific growth rate or the maximum population level. And so therefore, programming or coding, you can solve everything, but it is hard for beginners or those who only want to quickly obtain model results. So we have to use some integrated tools. Like 10 years before, there already had some integrated modeling tools, especially for predictive microbiology. I think you know, such as DMFit, like developed by the Joseph Browning. He also built in the DMFit tools in the Combase website. You can use it until now. And also the GenaFit from Grant University. And they are all easy and useful for modeler to obtain the microbial kinetic parameters. And however, there was a blank in China at that time. So we don't have any tool related to predictive microbiology in Chinese. But sometimes we always have some questions from the government or the company. or even some newcomers in the food microbiology. They ask us if we want to build a predictive model on some microorganisms, what kind of tool can we use? So maybe they need a big time to learn some programming skills, and therefore our team has decided to develop a tool that is simple enough and a tool that can allow one-click modeling to assist us in teaching and research. And here is you can see a brief milestone of our tool. So we start from 2012 until now. We still keep developing. And in 2017, that's a big milestone. So we started to systematically redesign MircroRisk Lab using R and Shiny app. This change helped it become a web tool and can be easily shared for others. And after several iterations, we found some bugs and then we fixed them. And then we published our first open release, version 1.2 in 2020. And we published a paper on the Journal of Foodborne Pathogens and Disease. I think maybe some of you have read it. And this paper was supervised by Professor Dongqing Li. He is also the PI of our lab. And we are very happy to hear that some of your work is modeling and teaching with this tool. And then last year at Food Micro in Spain, I have seen some of you in there, and we previewed the core updates of version 2.0, which will officially launched this summer. And when you scan the link, and you can visit our current version. Is version 2.0. Okay. And then I will introduce the backend of the MircroRisk Lab to you. And actually, MircroRisk Lab was developed based on R, as I said before, because this language is open source and widely used in scientific modeling, also to solve some mathematical problem, and also good in statistics. And the Shiny package also provides an elegant framework for building web applications. And these solutions with R and Shiny apps are also widely used in many predictive modeling tools in recent years. I think some of you should will know that, such as like BioTool series built by Dr. Alberto Gary, and also the growth predictor from Professor Skattemeis from AUA. There are some of their tools also built with these solutions. Okay, and also in the backend, also thanks to the R open source community, our tool was realized on a suite of high performance R packages, and each taking on a specific critical role. And in this version 2.0, we also further utilize the package family of tidyverse to improve computational efficiency. And we have optimized the visual effect by using CSS languages. This help our tool looks more modern. Okay. Okay, so, and for the current version, MircroRisk Lab covers kinetic analysis for microbial growth and inactivation, and under both isothermal, or we can say static condition, also the no isothermal or dynamic conditions. And it also includes secondary modeling and competition growth fitting. Additionally, it supports both deterministic and stochastic simulations. Okay, and then we look a bit closer at the models, and for the isothermal growth models, I think some of you can read in many books or papers. We have integrated many of well-known primary models This includes widely used models like the Compass models, the Veroni models, and the Buchanan models. We also include some like without the lag tide or without the maximum population densities models, and also the linear models. Okay, and for the no isothermal growth, which we also sometimes we call it is dynamic models. And we provide, in the current version, we provide the Bernoulli cardinal models and the Huang cardinal models, according to many published research on dynamic modeling. And actually, you can use any growth model and no growth model, I mean the primary models, and also with the different secondary models. But for this tool, we just integrate two models, but we can add more models inside later. And we have also include a comprehensive set of isothermal inactivation models, such as the Garrett model and Weber model and the Vigilote models. And this also depending on the shape of their data. For example, it has a shoulder or tailed or not. Okay, so this is our inactivation models built in the MircroRisk lab. And just like the groups, we also support no isothermal inactivation modeling. And this is also a very good model for the pasteurized or cooling procedure. We have implement like dynamic Webull and also dynamic visual models to address this scenario. And sometimes we also need to consider the impact of the background flora, I think in some of your research. And so therefore, we also added two Jameson effect model in here. And these models are basically a reference to the package called NLS microbial. And from the study of women. Okay, and secondary modeling is another important component in predictive microbiology. And MircroRisk Lab provides a selection of common secondary models to describe the effect of temperature, pH, and water activity on the growth parameters. And we also using approach like square root and cardinal parameter models for these different conditions. And this is all the models we built in the MircroRisk lab. Oh, okay, so maybe we will add more in the later version. And also to help users evaluate their results, the tool also can calculate a full suite of statistical indicators. And you can see we have different families and for this tool. So like the first two lines is kind of sum of square errors and mean square errors and rule mean square errors. And this measures the difference between the observed data and the predicted data. And the lower values means a better fit, I think you know before. Then also we have different family like information criteria, AICPIC, or the adjusted or credited AIC indicators. And good models should fit well without being too complicated. So we always say this is like outcome results. And we also want to avoid the overfitting situation. So these AIC and BICs help us to judge the results if it is maybe have some risk of overfitting. And for example, if two models have similar like RMSC and the one with lower AIC, we think is better. And we also have include correlation coeficients and the confidence intervals for the parameters. Okay, so this is all the statistical indicators we will use in the MircroRisk lab. Okay, and above is the backhand, and this guys shows the typical layout of a MircroRisk lab. It can also well adapted to the screen size of different smart devices. You can use your phone. If you are in the lab that you don't use a laptop, you can use your phone to type the data inside. Then you can quickly to get modeling results. And also we decided to be as simple as possible. And when you using the computer, it will look much better. And on the left is the main menu, and you can select your function in here. And then in the middle, when you choose a function, and in the middle is the setting panel, is where you can input your data or choose your models. Then you click optimization and also the fit, and then you can get a result. So on the right hand, you can see the results panels, and and this will display all your outputs, including parameters, statistics, and also the fitting curves. And also you can define the fitting curves. So later I will use some case studies to show you this. And that's some background information of the MircroRisk lab. And perhaps the best way to understand the tool is to see these actions. So I will use some case studies to show you. So, and this time I will make like 7, okay. Oh no, six case study actually to show you the capabilities of this tool, and we including the primary and secondary modeling, and also two-floor competition growth modeling, and dynamic growth modeling, and also the model simulation. And if you have another device on hand, you can also access MircroRisk Lab and follow me to complete the case studies. And all the case study, the data of the case study in the later example, you can obtain the data from this link. You can visit it and you can use the data inside. And if you have some device, you can go to our website for the MircroRisk laptop. Okay, so let's start the case study. Okay, and for the first one, it's a kinetic analysis of Listeria ghouls. Okay, so since this is the first example, I will explain it in detail and do it step by step. And for this case, we are using a classic data set from a 1990 paper by Buchanan and Phillips. Yes, and then before it we can download from Combase from the data set from Combase, but you can also find the data in this link. And this is a set of observations on the growth of Listeria in the laboratory, the culture media at 5 degrees. You can see the Combase data is in here. Okay, and then when you enter the certain modeling function, you can fill the table by typing data or pasting data from other data files. You can see that here, and then you can choose the unit of comes. So I will do this lively, and here is our data. Okay, so you can choose it. You can also copy from the Excel or any other software, and then you open the MircroRisk lab and then choose groups, and then you can paste the data in here. And we also provide the options for the units. You can see the unit of counts. So normally we use log the logarithm weight based on 10, and you can also use the natural logarithm, also the counts to do that. So normally we use log 10. Okay, so and then when you down the data, okay, so I need to also explain to you. You can also type like 500 here, but if you won't type the counts, it will counting in the model, because we also have a program background. So to check if the row is complete. So if you delete some data here, okay, so these 240 hours will be deleted. Okay, so it's like that. And then we copy that again. Okay, so then after, so and from the list, so you can, after that, you use the optimization button. So in this version, we, oh, sorry. And in, okay. So in this version, we provide the optimization function to you. You can first to use this button. The software will run in the background to choose the best model by the RMSE, and then you can from the list you can see the logistic model in here provides a better fit for this data. So after choose the model, then we can click the fit button, and then you can immediately you can see the results in the results panel. Okay, you can see that. And the results panel will show the estimation, the results, and also the evaluation results, and also the curve fitting. Okay, so users also can choose the number of decimal places to keep keeping the eventually to convert to the logarithm or the base 10. Okay, you can choose different decimal to the results. Okay, normally we use two, but in some parameters like Mumax, we have to use more the this mode. Depends on the what you needed. Okay, and okay, so normally, so the results we showed immediately, but actually when you visit MircroRisk lab at the first time, it do the task, it have to wait some minutes because it need to reload the package in the background. After that, in other task, you will immediately get the results. Okay, and because this is due to the Shine apps, they need some time. So. Okay, so as in the next slide. Okay, so next slide is in the curve fitting tab, and you can see the interactive pilots showing the row test point in blue, and you can see the test point and also the fitting curve in the orange. And then you can see this fit is excellent for the logistic models, and you can zoom the pilot and also zoom out, and then also crop it, and also to download the curve fittings. So then I will show you, and you can like zoom, or no zoom like this. It's like this. You can check the different data point on the line or also the point, and you can get it back. And also you can change the title, the label of Y or X. You can see we can have you can change anything, good or anything. You can see it will change immediately, and also the label. Okay, and then you can also use the camera to download the pilot, and like this you can get the pilot in immediately, like this. This is the Y download from here, and then you can. Sorry, you run it? Yes, this kind of demo for MircroRisk Lab. Okay. Okay, so let's keep going, and then we can also provide the CSV files of fitting and simulating data from here, from this button. You can get the results. Okay, so I will open it. This kind of, okay, you can see that this is fitting results from the MircroRisk Lab. Okay, and then you can get results for different models. You can choose different model from here, like Huang models, the Brownie models, and Compass models. Okay, and also different models, and you can check the results and also the curve fittings here. Okay, and you can from these tables you can see the languages models with the lowest RMSE. So we choose these like the best models. Okay, so this is the first case for the goose models. Okay, so and the second case is isothermal inactivation fittings, and this data was also obtained from Combase, describing the behavior of E. coli under low pH value. Okay, if someone asks me any questions, I can see. Okay, it's on that. Okay, it's on that. Then, sorry, we keep going. Okay, and this fitting process is the same as the first case. We can obtain the fitting results in the curve by optimization and then fit. You can get the results here. And you can see the fitting results for the inactivation models also. And then, okay, so and then we can get tabled for some models from here. And with the RMMSE, we know the no shoulder two-phase model is better choice. Okay, so like we can have this data. So I will do that again in case you haven't seen that before. Okay, so for inactivation models, you do the optimization, and then you immediately show the no shoulder two-phase model is the best, and then you can have other choice. You fit it, and then you can get the models. Okay, so and also different models like Weibo or the no shoulder Garrett models. Okay, like this. Okay, and for the third case, a demonstrated secondary modeling. And here we are using data from a 2002 paper from Dr. Oscar, which provide the temperature and the corresponding specific growth rate of salmonella on chicken top. Okay, so this is his paper. It's original curve like this. This is the data he provided. Okay, and the operation method is similar, and the unit of maximum, but the unique of maximum specific growth rate is based on the natural logarithms. So we do not make a choice for you because it's normally use the natural logarithms. And then we can get the results, and you can also briefly offer the secondary models that considers interaction effects. But the results was not very good before, so we have to use the single conditions for that. And now we are planning to integrate methods such as also with the response surface, growth or no growth modeling, and also the artificial network in our future versions to enhance the functionality of the secondary modeling. So until now, we still only provide the temperature, pH, and also the AW secondary model to you. Okay. And this is the resource, and we see the cardinal parameter models is the best, but it should be noted, you can see that in here we have lower like RMC SE for the cardinal parameter models, but we have lowered AIC or BIC values for the full square root models. So in this type, we have to balance. It depends. It depends your core the research goals. If you prefer the good description of the data set, so the existing data, you can use the cardinal parameters to models to describe the data set. But if you want to use the model for predictions, because like this AIC maybe is higher than another one, and maybe they have some risks in overfittings. So it's better to use the full square root model. So, but we think anyway, we think both models are useful. It also it only depends on your the core the research goals. Huh? Okay, and also we can do that from here. Here is the data set for the secondary model. And you like this, and then copy, optimization, and then fit. You can get the results, and you can also see it from the line. Okay, it's the same as before. And okay, so for the next case, as mentioned before, for the competition models, actually we reference from the work by Dr. Womant, and you can see his nice work in AEM, the paper in the Journal of AEM, and you can check the papers. He did a great job for the competition model. He provided a very easy way to model these two furrow grooves. Okay, and in this case, we can see we need two lines of the data set. One is the grooves of the furrow 1 and also the furrow 2 counting counting results. And maybe the furrow 1 is the what you want to know. The maybe is your target passengers like E. coli here, and also the furrow 2 is the background microflora, and then you can use this data. Okay, so in our tool, we provide like 3 lines in here, and you can use enter the data for the both flora in here. Then it will provide the kinetic parameters for both flora 1 and also flora 2 separately, and then in our next model step updates, we will also include like the local bacteria, like we also call it L-weed model families in our next update. Okay, and here is the results for the competition models, and you can see the model with the Yangtai is better. Okay, so we do that here, and we copy the data, and then we go to the competition model and then copy to here, and okay, so optimization fit, you can get a result. Okay, if you have your own data, you can try yourself. And then okay, so for the next one is the 5 case, and the no isothermal growth fitting also is very important features of MircroRisk Lab. I think we are the first tool to provide no isothermal growth fitting. Okay, so it can help modelers to achieve one-step modeling using flattening temperature data and also the microbial counting data. And we also can append the parameters of the primary models and also the secondary models together in one fitting. And I will use a set of observation data from our laboratory for the demonstration. Okay, and here is you need two data sets. One is for the high temperature profile, and another one is time and counting data like this. And then you can use these two data to do this job. Okay, so we first to entered our temperature data in the first panel, and then you choose another panel. You can use the counting data here, paste to here. Then you use you can see we have some the choice for the initial guess because this model is too complicated. So we have to first to set initial guess for different parameters, and we have some like a setting before. So you can see the simulated curve is like this, and the observed point is in blue, and you can see the fitting is not very good because the orange line is more higher. Then we have to change the initial guess to make it more fit. And then you can use the optimization, and then you will see a better initial guess like this in the below the pictures. And then you use the fit button, and you can get the formal results for the fittings. Okay, so this step make our modeling more easier. Okay, so and then we can get results from here. And for this case, you can see the Brownian cardinal parameters model is the better model for this case. Okay, so let me do this for you again. And you have the time temperature profile here and also the counting data here. Then you can copy this to here, this function. You can put it here. Okay, and then you can also choose the counting data to here. Okay. Sorry, like this. Okay, so first you use the optimization button, and you can see it's not really good. So maybe you have to change a little bit for this this target. Okay, this parameter. So maybe we have like 0.5, and then we optimization. You see it's closer. Okay, so maybe we lower. Okay, more closer, and then okay, maybe it looks better. Okay, then we can use the fit button. Okay, then you can immediately get the results. Otherwise, maybe the modeling will fail down. For example, if we like type like 2 or maybe more or 50. So like, okay, see. So if we fit it, you can see the regression will be failed. This is because it is a complicated models. If you didn't give him a good initial guess, it will possible to give you a fail modeling. Okay, so you have to use this initial guess. It will be better. And if you see the layout is not quite good, you can. Okay, so let me do that again. Then you can get the results, and you can close this. Okay, so then you can get a normal layout for that. And this is also the parameters for the primary model, and also for the secondary model. You can get a result in one fitting, and also the curve fitting here. Okay, so you can also only see the temperature, or only to see the fitting curve, or also download. Okay, So this is the main features of the no isothermal growth modeling. And I won't use a case study for the dynamic, but we have also updated more of these functions like the growth modeling. And about this, I also recommend to you the bioinactivation tool by Dr. Gary. I think you know him, and from Spain. And it is his tool is more professional with more models and can customize many parameters items if you want. So I also recommend that to you. Okay. I won't use a case for the inactivation model. And the last case, okay, so I would like to introduce the model simulation of MircroRisk Lab. And for the deterministic models, okay, once you have determined your models, like we have also built in many models inside. If you can confirm your target model, like brownie models, and you have the results, your modeling results before, like the maximum population density, Yangtai, or MuMax, you can set all the parameters here, and also the conditions. You have the initial counts and also the time you want to predict. You can set in here, and also in the parameters, you can see we have an option to you for the specific growth rate. You can use if you know the exact value, you can use this, or you can use the cardinal parameters models if you know the the features of the microorganisms, and you can also use these cardinal parameter models here. Okay, so for this is for the deterministic simulations, and then you can use the simulation button. Okay, so this is okay. Sorry, and there's something wrong here. Okay, so in the MuMax, you can see the line here. Okay, and for the conditions, if you want to see the whole models, you can change the time like 30 hours. Okay, or 300. Okay, you can get a normal one. If you don't want you don't need if you want to reduce Brown models, you can use like that. And if you want to use like the without lag models, you can just type in the lag here, and you can get this without lag Brownie models. Okay, and this is for the deterministic models. And in addition, and we also use a Monte Carlo simulation method to calculate parameter of the possibility distribution or the predict stochastic growth or activation process like this. And this is very useful for the single cell level and also the further the QMRA. Okay, so for this, I will use an example to demonstrate this function to you. And this example also comes from Professor Kusmani's research on the individual cell of Salmonella. And he done the excellent work before and determined the growth parameters of Salmonella cells at different population levels. You can see this is different population level, start from 1 cells to 10 and then to 100. And this is different level of single cells. Okay. And here's the setting for the 1 cells. So we just use the parameters from his paper. He determined this for the Salmonella here. Okay, so and he have okay, so the initial one is the 1 cell. So for the initial initial population, we can use the normal distribution to describe these parameters. And also for the Ymax, because this model is not the end, so we use like a prior value, like a or something like 10 if you want. So this won't influence the results. It's just a setting up. So we use a here to say the maximum population density, and also from his paper, we can use log normal to present back time and use the logistic distribution to present the mu max. And for the time, you can use uniform to represent it. And in this research, when we read his paper, actually for the single cell level, we can use Buchanan models to describe its growth, and he also used in his paper. And then for the iteration types, we can use the 10,000 iteration types to for the Monte Carlo simulations. Okay, so this is a setting. Then we can set the parameters or values in our stochastic panel, and you can see from here we also built in many possibilities distribution for different parameters. Here you can use the values to input it, and then you can see the results from here. Okay, so let me do that again for you for the simulations. Okay, so you can see this is deterministic. When we choose stochastic, actually it has already had results. So for this case, we choose Buchanan models, and then you can use different settings like the maximum. So like SD, we use 0, and then for the back time. So according to this research, we can see it is log normal, and then we choose log normal, and then use the 3 point. Okay, so we just use similar one. So the SD, we can use 0.9 for the shift. We can here. Okay, and then for the mu max, we use like the logistic model here. Okay, so it's
Recording
data
is
for predictive
on.
modeling and QMRA. And this is a preview. You can visit our link here. And this is a preview of a knowledge graph for passengers. The idea is to take data from resources like Combase or published papers and even our old experiment data, and then represent it as an interactive graph, allowing users to visualize and explore the relationships between the information of organisms, like is typing of foods, and also some experiment records for that. So this kind of preview for our graph, knowledge graph. So we will improve that. Then we will put it online. And for the microbiological risk assessment, we also build an online version of Risk Ranger, depending on the well-known spreadsheet developed by Professor Rose. I think all of you know this great tool. And we launch, yes, we also allowed it by the Professor Rose, and he also think it's a good idea to put it online. And we launched the Chinese version last year with an independent link. Sorry, sorry for you, because this is in Chinese, so the English one is not online. And because this application is very used, quite frequently in China. So in for the government's works and also the company works, it will help them to quickly assess the risk by answering a series of questions. As you know, it's 11 questions and about the hazards, the food, and also the process. And this allowed them to efficiently make horizontal comparisons between different risks and then make a decision. So we have already launched the Chinese version online like that. So after that, we integrated the English one and also the Chinese one in the MircroRisk app in the later version. And also for the QMRA, so 5 years before, we have also developed a food modular QMR function for CIFSA. As you know, is the China National Center for Food Safety Risk Assessment, which is a big authority in China to help to do all the food risk assessment like EFSA. And this tool let users easily build a complete farm-to-fork possibility risk assessment by defining parameters and connecting different models. So the idea is similar to MircroRisk app. We just want users just like choose and click, then he can get a risk assessment results. And we are also planning to add this feature to MircroRisk app as well. Okay, and this is some of the feature outlooks on our tools. Maybe if you have any suggestions to you, we are very welcome. Okay, and at the end, I'm also very pleased to hear that MircroRisk Lab has been widely used by peers in their teaching and research works, and you can see all the papers published in the recent years is use a MircroRisk Lab to realize the fitting process, and this also inspires us to keep moving forward. Okay, and I would like to thank the support from my group and the MircroRisk team, as you see, directed by Professor Dongqing Li, and welcome you all to visit Shanghai and USSC, okay? And okay, this is the end, and thank you all very much for your time and attention. And please let me know if you have any questions. I hope we still have some time for Q&A, okay? It's 1 hour, okay, I finished.
Thanks very much, Yangtai, for this nice presentation. And it's really it's good to see that these tools are developed and that helps the people to apply the predictive microbiology approaches. So thanks again for all the effort made to develop such a tool. And yes, indeed, we have some time for questions. But before that, I would like to remind all the participants that please to fill this attendance form in order to get the certificate. So let's start with some questions that we have from the participants. And the first one is a more broader question, is related to the main challenges that you got when developing such a tool. So when you have to think and start developing this type of tools, what is the first thing that it comes to your mind, no? In order, okay, I want to reach this target audience, how to identify the needs of this audience?
Okay. So you mean the idea we developed this tool, right?
Exactly.
Okay, so actually in that time we first developed this tool for the beginners. So at the first time it come to our minds because for some beginners they maybe they confused about the programming or the step and also how to really to realize to model something. And then we also have this problem for some students because they did experiment, they get the data, but when they need to model it, maybe it takes 1 day or 2 days by using some programming software. So we try to use this. We develop like this tool to help them to face with this situation. Okay.
Mm-hmm. Okay, and according to your experience, because as you said, this tool is aimed for people that maybe has not too much experience with predictive microbiology tools or want to do it faster. According to your experience, when they input the data, when we have to input the data, what is the criteria to check that the data have the right quality? No, because at the end we can fit all the different log counts that we input in the system. But what is your recommendation when deciding or not to include a particular log count, for example?
That's another question actually, because so we just provide a tool for you, but if you need to check the qualities, so I think in the previous lectures you have discussed about this. So normally when we model the data, so in each log, we can check a point for that. If you will get a best data set for the groups or in activation models actually, and in even for the no isothermal dynamic modelings. Okay, so maybe I will share this screen. Okay, so like for the dynamic one, normally we use like you can check the when the temperature change and also when the counting data go one log, then you can get a very good fitting results. And also for the groups model and also for the inactivation models. And this is how to check the data quality. If you do like this way, so normally in our lab, we sometimes we have to do many, pre-tests before, then you can get a good condition for when to get the counting data. Okay.
Mm-hmm. And then there is another question regarding this non-isothermal growth or inactivation that we are here fitting or sometimes even predicting is regarding we have different temperatures that we record along different times, right? So when modeling the temperature between these ranges, which is the value assumed, no? Imagine that we have at 1 hour, we have a temperature of 5, and at 10 hours, we have a temperature of 10 degrees. So the time between 5 to 10 hours, which is the temperature assumed there? Or do you assume that it's, for example, 5 degrees, or it's increasing towards 10 for the dynamic modeling?
Okay. So sometimes, okay. So this one we use decide this one we use decide the temperature profile. Actually, you have to use the observed temperature. It will be getting better. So like in our lab now, when we do these modelings, we also use detection for the temperature. So like 6 minutes to check the temperature once, and then you can get a real temperature profile here. Okay, then we will get better results. It will be more like a reality. Okay.
Yeah. Thank you. And another question that it was made is during the simulations. It was highlighted during your presentation that for fitting we use the growth rate in LN units, but for simulations there is not specified which unit we should use. Is also LN or?
Okay, so I'm sorry, I didn't mention it. So no, so in the MircroRisk app, we normally use log 10 for all the counting data. Okay, so like the results I also showed in the log 10. Even you use the LN or the comps data, you will get the log 10 results here. Okay, so like this, maybe I will share the screen. And even you choose another unit, you will get a log 10 results here. So
but
this
the
is
units of the growth rate?
The growth rate is all ln. So it's natural logarithms.
Yeah.
Because it's definitions. The specific growth rate, the unit have to be a natural logarithm for that. So yeah.
Okay.
Okay.
Thank you. Yeah.
Okay.
And regarding also now that you are here with the fitting, we receive another question regarding this optimization method that you highlighted, that the fitting can be optimized by and ranked by the root mean square error. So here the question that we receive is if we always have all the models to be checked, or it's of the models that we have for doing the fitting keep changing according to the values that we input.
Okay, normally we use the best one is okay. It's enough. I mean, so you can use the best one, okay? So if you want to check another one, you can check. That's
Okay.
I think this freedom to you.
Yeah.
If you want to compare different models, okay, so you can compare. Okay, so normally we directly use the best one, but that's the situation for, I mean, this situation you have to be careful like this. So we have like RMSC and AIC I explained before. So it depends your target. If you want to describe the data set, you can use the cardinal one. And if you want to use it to predict something, you can use the best in AIC one. Okay.
Yeah. Thank you. We receive also another question regarding the future updates on the tool, and you have shown a lot of different models that are integrated in the tool that relate to microbial growth or inactivation. But the question is if at some point you think that it will also be extended to growth for fungi.
Oh, for fungi, fungi, you mean?
Yes.
Because funky modeling is quite different. Sometimes you can use the passenger ones, okay, but sometimes it is to check the size of the fungi. So we have different models. It depends. It depends. So yeah, maybe I will check if we can include some funky models inside. But I mean, the detection rate is sometimes is different from the pathogens or bacteria one. So
Yeah.
I have to check later. Okay, thank you. Thank you for your suggestion.
Yes. And regarding the competition models, so far
Okay.
it's implemented the Gemson model. Do you have also plans to implement, for example, Loctable Terra or other type of competitions models in the tool?
Yes, yes, of course. I'm sorry, maybe I mentioned it. I forget to mention it. So for these models, we reference from the WOMIT study. Actually, we didn't have a big work on that before. So we also know that we can use like LV models or different Jameson effect with Brownie Huang models, or also the Gompers models. Yes, I will do that. We are creating the models from the different papers to see which one is commonly used. Then we will add it in the next update. Okay.
Thank you. Another question, and this is more a broad question, it's more, let's say, philosophical. These tools are really nice, and we have one of the participants that just asked, what are the main challenges to keep this tool updated? No, you said that you plan to introduce new models in there, but from your point of view, when we develop these tools, what are the main challenges in keeping them updated? What do we need for that?
You mean the main challenge to update?
Yes.
Okay. Hi. Come on. So because now I have to teaching and also research. So normally every week or month I will check if someone email me they have some suggestions or some they have some feedback. So I will check if they have some feedback. Then I will see recheck all the codes again. So like every month I will do that. And also so for you can see in the version 2.0, so our current versions, the optimization function also suggested by someone from American, and she texted me. She said, "Okay, so when I use some data, it will feedback the failed regressions. And I don't know how to choose a good models, because in our formal versions, you have to choose the model as you own. So in this version, we have got her feedback. Then we change all the design, all the logic for the modeling. So now you can use optimization, then fit. Then you can normally always get the best models in the first. Okay, like that. So
Okay.
So I think we need more feedbacks from you. Okay.
Yeah, indeed. I agree. Thank you very much, Yangtai. The last question that we have here is if that is possible to see also the confidence intervals of the fits in the tool.
You mean the Starbucks? Okay. So yes, we didn't provide the Airbus here, but we just like this. If you have 2 time point for that, like you also have like okay, I can also type a middle time. Like in 240, you have another point. You can have do this around like 0. Okay, then you can see here is the point. So you can see the parameters, it also changed. So we consider this point actually. Okay, so we don't use error bars. We just showed all the points you inputted, and you can see the results. It's also consider this point, and maybe you can have 72, and you don't need to see the these are okay. So like this, yeah, fit. You can get this. Okay. So the results will change. It will put all the input data here. Okay.
Okay. Yeah. And then we have another question, and here is also more broad. Maybe you haven't addressed it during your presentation, but maybe it's also possible to use in your tool. Is if we can predict the growth or inactivation of microorganisms in food.
In food?
Yes.
You mean the simulation, right?
Yes.
So for this, okay, for the simulation, actually, we just put like, if you know the inactivation rate here, and then you can put it. It's just like a calculator, okay? So it doesn't matter about you are in food or in the laboratory culture. It just related to the parameters. You can set the values here, and then you can get the results. And like this, you can like this simulation here, okay?
Okay, but you need to estimate previously your inactivation rate or your growth rate. It's not that there are some models already in the tool that are
yes.
Okay.
Yes. Okay.
Yeah. So thank you. I don't know if there are other questions by the participants. Please raise your hand or feel free to write them in the chat now. No more questions? Then I would like to thank you again, Yangtai, for all your time, for all your effort, and for this nice presentation. I think that it will be very well appreciated by all the community. And thank you for keeping on communicating all our work and the nice results that we are obtaining, and how the predictive microbiology can support in the management and the safety of the foods. So thank you very much. I would like also to thank Bram and Natalia for their support here in this webinar today. And I would like to invite all the different participants to keep updated on our LinkedIn profile that we will update soon on the next webinars that we are preparing. This is the first webinar of model number 3. And this model is aimed to show different tools and softwares where we can apply predictive microbiology and quantitative microbial risk assessment tools. So keep it updated on our LinkedIn profile, and see you soon. Thank you very much, everyone.
Okay. Thank you, Christina. Thank you, everyone.
Bye.
See you.
Oh, actually, before leaving, could we take a picture?
Oh yeah, sorry, I forgot.
Ah,
Yes, please, participants. Yangtai, please stop sharing your screen. Thank you so much for your presentation. It was very good. Very, very good. Yeah, we see here the feedback. The participants really enjoyed the presentation. Perfect. Let's give it 1 minute for everyone to open their camera so we can take a picture, record this moment. Yeah, and then Bram can take a screenshot. Okay. Let's just wait for Bram.
Yes, so I'll wait a few seconds, and then if the small bar on my screen is gone, I will take a picture. Okay, so I suggest we say Liu instead of Cheese now for his amazing presentation, and I will make a picture in 3, 2, 1. Cheese. Yes, excellent. Thank you very much,
Amazing.
and see you soon.
Thank you, everyone. Bye-bye.
thank you. Bye-bye.
Thank you, everyone. Thank you.